For this demo on relative accuracy assessment, I have the LiDAR data loaded in ArcGIS along with the orthophoto backdrop image. To generate a DZ ortho image, we're going to again open the export wizard. In this case, we're going to use all source points. We're not going to restrict ourselves just to first returns. We want to look at comparison of elevation of all points in the overlapping swath. There is no hard and fast rule for cell edge length in this case. It's a good idea to pick a cell size that's large enough to cover at least a couple of points from each flight line, but not so large as to be comparing actual different elevations. So a rule of thumb is to use something slightly larger than twice the nominal point spacing, which in this case was, let's say, roughly 2 feet, so we'll use 4 feet as our cell edge length. We need to change our surface method to point insertion. We've got our 4 map units for the cell edge, and we're going to choose DZ images, and now we'll get the DZ tab. The options here are analogous to those you saw in point density. We can produce an output graphic. It can be color-coded according to intervals that we are allowed to customize. So in this case, I'll give it 5 intervals, and I'm going to have each one be an increment of 0.2 of a foot. So it's going to show me differences in elevation from 0 to 0.8 feet. And notice there's a checkbox box for absolute value. We're really only interested in the magnitude of the difference in elevation, not the sign. If I uncheck that, notice it changes to signed values. So I'm going to leave that checked on. Okay, I'm going to go ahead and execute this for the entire active LiDAR layer. Again, this may take a little time. If you're following along at home, just be prepared for that, or select a smaller area. I'll give myself an output name, DZ, and insert the output to the map. Okay, that took about 10 minutes, 11 minutes to complete, and here is the result. So notice that we only have a DZ information in the area where there actually is overlapping data. In the DZ images in the area between swaths, they just fill it in with LiDAR intensity. Again, because this is ArcGIS, we need to undo the default adjustments that were made to the symbology. And now we can see the color coding that is indicative of the legend that we created. Let's go back to look at that legend again to remind ourselves of the meaning of the symbology. So green means there's a DZ, or an elevation difference of between 0 and 0.2 of a foot. This would be very acceptable. And red is an elevation difference greater than 0.8 of a foot. Notice that we do have some fairly extensive areas where we have large DZ differences, but these are almost exclusively in areas that have vegetation where we expect and it's acceptable to have such differences. I am not going to cover the swath-to-swath analysis using seam lines in this tutorial, and you're not going to be required to do that in this lab. But if you're interested, please refer to the LP360 training exercises, and you can go through the steps that are outlined there.